right. Welcome to Standing for Truth. This is day one, session 2 of our Defending Genesis Conference 2023. In this session, we have Matt Naylor from the SFT Ministries to give a presentation on the Ark animals. I'm pumped for this, as Matt has been doing a ton of work and original research for this presentation to remember. Matt, how you doing, brother?
I'm doing good. Yeah, I look forward to this one. I'm trying to always bring people unique kind of concepts and novel information, and I dug deep on this one for everybody. So hope you enjoy.
I know you have, brother. You've put a lot of work into this, and I'm excited for myself to sit back and listen to this, but also for our audience. This is an important topic, and why don't we get right into it, Matt? So whenever you're ready,
Yeah.
brother, floor is yours.
All right. Let me do some screen sharing here. Make sure everyone can see. Looks pretty good. What do you think of this view? Should I put myself down below, or is this good?
No, I think that looks good, brother.
All right. Well, today we're going to be trying to narrow down the specific animal species that was on the ark with Noah. Obviously, we're going to have some trouble because a lot of species have gone extinct since that time, but we're going to do our best to use every available possibility that there is. Now, this is kind of similar to the phylogeny challenge that was posed by the critic Satanist R. and Raw, who said, name a creature that God created. This is a very hard thing to do because we're going past a global bottleneck, which would be Noah's flood, and we're left with only fossils. But the good thing about this is that we have the genetics to go by. So therefore, before we get into that, I need to explain to everybody the model of the young earth creation, which is genetic entropy, and how we're going to narrow down the animals that were on the ark based on this model. So the first thing is that the model predicts that over time, larger organisms genetically go downhill. You've heard the term probably loss of information. I'm going to explain what that is for those of you that might not know or have never heard it before. And I'm going to change one thing on the visuals so you guys can see even more. Nope, that looks horrible. Never mind. Okay, I'm going back. Okay, now, the biblical model of ancestry is built off of what scripture tells us, right? The scripture tells us that God sent 2 of each kind to Noah. They got on the ark and they got off and filled the world again. So therefore, we created a model that would be based around that if it was true. And we made predictions on these things. So what we would find is that if an animal's only 2 of them got on an ark, they would have to inbreed, get off, and then increase in homozygosity, and then once they fill up the earth, we would only see a downhill progression after that time, and an increase of homozygosity from heterozygosity. Okay, so then we're going to get into the genome size. We would predict that genome size decrease over time. The same thing as having chromosome fusions, which means there's chromosome loss over time. Then we can also find that there were mutation accumulation over time. So all of these things will allow us to not only gauge and go backwards in time and make predictions on when these things happen, but also be able to deduce where these animals were, where they diversified and where they originated. And we should find a very consistent theme based on what scripture tells us, as opposed to what evolution says, where things can evolve anywhere and arise anywhere. Is that really what we see, or do we actually find more what's indicative from scripture? So that being said, what is information loss? It's the idea that over time, as things speciate, they lose genetic information. And because of that, they can never regain it. You cannot take a poodle, a pug, or a chihuahua and ever re-scramble their genome and create a wolf again. Its ancestor is superior, and therefore we see loss over time. And that is what genetic decay, genomic decay, genetic entropy, there's a lot of different names. Whatever makes you happy, use that term. And that is what we're going to go by. So again, we want to try to narrow down what animals were on that ark, what were the life forms that got off of it, and what happened. So to describe the first steps, we have to know what exactly happened right after the ark landed. And the global flood caused volcanism. And when volcanoes go off, they throw a lot of debris into the atmosphere, creating an ice age. And this ice age changed the topography. It narrowed where life could migrate to after the flood, and whole kinds of different things. Now, we know from history itself that volcanoes actually do create a little ice age and ice ages in general. This was one that we have in the history books that actually did take place. And scientists are actually worried about Yellowstone going off because it will also plummet the Earth into an ice age yet again. So we know the model, again, is we're basing it off of what we actually know. And we're deducing that from scripture what probably happened and when the ice age took place, and how would have this changed animal migration? What patterns would we see because of that? Now, this all comes into effect because we're talking about animal migration and things like Australia. How would they have gotten there? Well, right after the flood, the water levels, which it would have been much lower, and they could have simply walked to Australia. But then what happened is after the ice age, as the ice melted and the glaciers melted, the sea levels rose, and now we have everything cut off. And that's what we have today. So animals could not generally, obviously, walk to that area. So now we've covered what genetic entropy is. We've gone over the basis of how I'm going to be determining what animals were on the ark. And we're going to try to follow these things the best we can, because not all animals have their genome sequenced. Some of them died and went extinct, and we don't have that. But there are some things in history that we do have. For example, we have images, some of the first civilizations ever, that actually show a lion in ancient Egypt, for example. And they have stones, carvings that show the same thing. The scripture actually tells us that the lion was created by God in the book of Job. But if we have to go down the genetic route, we can. It's just much harder with cats because they have the exact same chromosome number to this day, and they're very genetically similar to one another. So we would have to be guessing based on mutations. And cats are one of those interesting things. In the evolutionary sense, they're known as a ghost lineage because they just arise out of nowhere and they're in the wrong spot. They don't have a common ancestor to anything. They just show up in the fossil record, fully formed as cats, and there they are. And obviously it matches up Y on our model very easily and very well. But when we go back to cats, where would we expect to find cats' origins? Well, again, we would expect them to get off of Noah's Ark and start to diversify and migrate. And they would be migrating because they would be hunting things that migrate, not because cats are migrators, but because they'd be chasing things like goats that are natural migrators. So we do find one of the oldest cats in Tibet. Interesting enough, right? Not very far away. Now, when we have to go to the fossils, cats are an interesting thing because a large cat is almost identical to a small cat. Everything about their bone structure is identical. And there is no real definitive good way to tell a species apart from one another in the cat family. So all cats are genetically look the same, genetically they are very similar. You can actually graft fur off of any cat, even your house cat, put it on a lion, and it would take. They're very, very similar to one another. So because of that, when we look around the world and we see all these different varieties of cats, they do go back to a single cat ancestor. And that is the cat that was on the ark. Now, what that cat could have been, if we look at mutations, we're going to find something a little bit different. Again, maybe the species is a little bit, not with us today. It could have gone extinct. But today we have a cat that has about 100 mutations total in it, looking at the CO1 gene, and no less than that. So it's obviously a pretty old species. I just made a random chart to show that a common ancestor of all cats is something that we would expect to see, not going back to a random ancestor of another animal kind. For example, a bear. We would expect to go back to a common ancestor of a bear. In the evolutionary model, it wouldn't be a bear, though. It would be a bear dog. And then you go past the bear dog into another common ancestor of the different branching lineage that diversified into other kinds of animals, right? Our model doesn't predict that. Ours tells us that we would go back from all the different bear species to a single bear kind. Nothing past that. No dog bear, nothing like that. And that's exactly what we find. We find the biblical model, and we can find that everywhere. Matter of fact, when we looked at dogs and wild canids, we go back to a single wolf. And that is indicative of what we would expect to find looking inside the genome of all animals around the world, no matter what we get. And that is exactly what we find. And the reason there is a lot of physical differences is because phenotypic differences are epigenetically regulated. So we would expect to find some visual differences. And it also shows us how much genetic diversity is within a specific kind. And it helps us identify what is a kind. Because when we look at hybrids and we look at genetic modifications and we look at breeding, we see the vast extent of what we could expect to find in the wilderness and in the animal kingdom within each kind based on that diversity we can force out of them through breeding. That said, we are going to jump into the first animal that was on the ark. And in doing so, I looked to see what answers in Genesis placed on the ark in the ark encounter. And they just have a generic wild boar kind. And it actually ends up being pretty accurate. So the first species we're going to look at would be the wild boar. And we are going to be focusing on the chromosome count. This is how we're going to trace them. They have the highest chromosome count. So therefore, they would have gotten off the ark. And based on genetic entropy or genetic loss over time, we would expect to find chromosome fusions. So therefore, the pattern of migration should be indicative of that genetic loss over time. Is that true? Is that what we're going to find here? Well, the ark, as you guys know, probably came to rest around here in Turkey area. And the animals got off and migrated, filled up the space, and then kept traveling. And as they would travel, they would have chromosome fusions. And that is what we see when we look at the next species, the bush pig or red river hog. They have 34 chromosomes, and they're only found in middle Africa. And they start to head down south a bit. Kind of like humans, right? They don't live up here. This is the desert now. So they got trapped in there as well. And then the next species has the least amount of chromosome would be the giant forest hog. And it is only down here in this region of Africa. And it has the least amount of chromosomes. So we find a very good pattern indicative of what we would expect to find as these pig species, boar, whatever you would like to call them, migrated around. And so we find that the highest level of observed heterozygosity falls with the first wild boar species. And over time, they lost and have become more homozygous, and they've had chromosome fusions. So those were most likely, the ark encounter got it right, that they were probably wild boar that were on the ark and got off. And when we follow this pattern, we can see what we would expect to find based on migration patterns. So here's another map that I created. And we find the highest chromosomes are in the wild boar, right nearest where the ark would have been. They stayed there, they migrated around. And then the farthest they got away, the speciation events caused chromosome fusions. And we have genetic loss over time. And we have newer species today. But nonetheless, we can track that back. So unless there was a different species of wild boar that is no longer with us today, we can be pretty certain then that we're looking at a wild boar as being the exact species of animal or pig species that was on the ark. So the next one we're going to get into are the beaver. I threw in some fun little pictures here and there for some of these animals that made me laugh. So we're going to be looking at the first one, which is castor fiber. Again, we're going by the chromosome number, migration patterns, and we're going to look at as much as we can, even some species that are extinct, because some of them we actually do have chromosome numbers for. Unfortunately, for the larger one that existed during the Ice Age, we do not have. And that would be the very large species of beaver. And they are extinct. They were, as they went over the pass and came down into North America, the Ice Age ended, and so did they, because they had adapted to that harsh environment and they're no longer with us. So whether that species or not was on the ark, I can't be certain, simply because of the fact that we don't have its genome sequenced, so we don't know. Therefore, again, we're going to look at the species that we do have chromosome counts for, and this is the one that has the highest. And again, we find it over here in the Northern Europe area, more near the arc. And then we'll notice that the pattern, again, is the farthest away we're going to get from those regions, the chromosome number is going to go down. And we are going to look at all of the different ones. Oh, sorry, the chromosome counts went from 42, we're at 40 now. And then I went to the Beaver project, and we read that though nearly identical in appearance, Eurasian beavers have 8 more chromosomes than NA beavers, and they cannot hybridize. So we see, again, genetic loss and genetic entropy where they can't even breed with one another anymore. They've lost information. They've had chromosome fusions. Only one has kept the original amount. And again, unless some random species that went extinct had more, we do not know. So we're going to say that the original castor fiber with 48 chromosomes was most likely the species that was on the ark. Now, of course, we could say that this extinct species was as well because of how far it got on its migration patterns. But again, we're going to go with the information that we do have and that we do know, and that makes the most sense based on migration patterns. And we again see that the higher chromosome number, it goes to the one that's nearest the ark. And as they spread out and speciate, they lose genetic information over time. So this would be most likely the species that was on the ark. The next one will be cows, bulls. And it's an interesting one because we have an extinct species, but we do know about them. And this is the auroch. Now, this bull lived during the Roman times. They actually used it in the Colosseum. So we have artwork of it. It goes back really far. Matter of fact, there's cave drawings that were supposedly made by Neanderthal a very long time ago, and they drew this bull specifically. It has the highest amount of chromosomes at 60. And again, it places us, the species is again nearest the ark. And then we are going to look at other species that came from that. And we're going to find that they are over here in India and moving down like they're traveling towards Australia. And we move from 60 chromosomes down to 54 and 56, looking at the African forest buffalo and gaur. And then the African forest buffalo is estimated allelic richness of heterozygosity and genetic diversity. It still retains a really high amount. And what happened is when we compare it to the Cape buffalo, which drops in chromosome count, a speciation event from them, then we're going to look at the next one, which has 52 chromosomes, which is the American buffalo, only found in the Americas and Canada. It has 52. And then we go to the least amount, which is the river buffalo, which speciated from the earlier one with the African forest buffalo. And we have this information on its genetic loss over time by seeing its heterozygosity drop off with this speciation event. So we can look at the river buffalo, and then when we look at the swamp buffalo, it has about half the amount, a little bit more than half. So a speciation event really takes it down a notch. So that's perfectly in line with what we would expect to see, a speciation event in the biblical model, losing genetic information over time. And this is what we see. And that makes it really convenient for us to look over and say, okay, what was the exact species on the ark? Well, let's follow that migration pattern based on chromosome number. And we will find the auroch has the most. And then over time, as things get farther away from the ark, speciation events happen. New species arise from that. And we get chromosome loss the farther we get away. And we can track that back in time right to the ark. And we can be pretty certain again then that the auroch was that bull species that was on the ark. So I chose a lot of hard animals for this presentation because there were some that were just so easy. I tried to challenge myself. And this next one is going to be a good challenge. And that is the rhinoceros. Now, this is the species of rhinoceros, again, from the Ark encounter. Oh, look at that dinosaur back there or something. Anyway, this species, here's another picture from the Ark encounter. A very young rhinoceros. You don't even see they have their horn yet. But there's only 4 living species of rhinoceros today. But that doesn't mean that there weren't more in the past. We can look inside the family and we find 3 additional ones, even others, maybe, that were now extinct. And you'll find that anything that really went north during the Ice Age and adapted to that region over the 1,000 years that it was an Ice Age, they didn't fare well when the Ice Age ended. Whether or not they got buried from the flooding that occurred in the region, or whether or not they died because the adaptation for their new environment was so quick they couldn't change that quickly, we don't know. But we will look at the map to find all the different regions that rhinoceroses lived in, and then look at the genetic information that we have. And we will find that the black rhinoceros that went south into Africa has the most amount of chromosomes at 84 today. And matter of fact, when you look up chromosome count, you find that the black rhinoceros has the most out of every species. Everything else has 82. So when the rhinoceros or any animal really got off the ark, the things that went north went extinct. We don't have them anymore. We don't have their genomes sequenced. And unfortunately, all we have for the most part is their remains. So when we're looking at the next species, again, we find the white rhinoceros down at the tip of South Africa, which obviously you would expect to find based on our model that they would have lost chromosomes. They did, and they got farther away. And then we're going to look at the ones that have 82, and they're up here in northern India under the Himalayan mountain range. And again, at the further tip, going again over to the Australia area. So the pattern matches yet again very good with the biblical model, that the further away you get from one species that's nearest the ark, you lose chromosomes over time. So what rhinoceros species was exactly on the ark? Genetically, all I can say with any confidence would be the black rhinoceros. It doesn't mean that it was, simply based on the fact that we have 3 species that got off the ark and went north. And it could have been the woolly rhinoceros, right? It could have been the one that didn't have a horn. But we just can't really know. But one thing genetically that we can say with certainty is that the patterns match again. Where we would expect to find rhinoceros. How come they're not just in America? Why don't we find them just in South America? How come they're not only in one region of the world? Why is everything always indicative to finding in the European area and branching out from that area? I think it's a pretty good indicator that we're onto something when it comes to patterns, and especially looking at genetic loss over time, chromosome fusions over time. So the next one would be the what is this? No, it's not an anteater. It's the armadillo. And this one has quite a few species, and their information is readily available. So this is really, really good. I was able to find that the 9-banded armadillo is the one with the absolute most amount of range at all. And so if it got off the ark and went into Africa, it also got trapped and then had made its way with the currents over into the Americas, and then branched out and just saturated the entire region. And when we look at all of the different species, we're going to find that the Glyptodon, which is known as the very large version of the armadillos that were seen in cave work that was killed by man, and as living, also having 64 chromosome along with the 9-banded one. Their region of diversity wasn't as great as the 9-banded one, and they've never found them on another on the continent of the European side. But we can find that the pattern again matches very, very well. The 9-banded one is only on this image, and then the Glyptodon is found here in this region only. And then we find the branching out pattern, a loss of genetic information, loss again. And then there's a reversal with the largest species that literally went back and filled up South America, one of the more versatile species, which is the largest of all armadillo species, which is called a maximus. And when we look at the giant glyptodon armadillos, we know that they were hunted by man because they found cave drawings of them. They found that they would hit them on the head and crush their skull, flip them over, and then make sure they were completely dead. And then they would cook them up and eat them. And so here's an interesting thing as well, is this took place in South America. Now, when did humans inhabit South America? In our model, it would have been much out. It would have been one of the last places on Earth, right? They would have migrated Native Americans over through the Great Bering Strait into North America, migrated there, kept going into South America, Aztecs, Mayans, and then they would have encountered these creatures and hunted them. So again, the pattern matches perfectly with exactly what we would expect to see with a biblical model. Migration, leaving. We find the ancestor nearest the ark would be the 9-banded armadillo. Again, we would expect it to have the most amount of chromosomes. It does. We find 2 different varieties of them. One, the same species, but in 2 different places in Africa. And then they vanish from there and end up over in Americas. So it's obviously a recurrence, and would have rafted them over there into that region. And from there, diversity, speciation events. And the speciation events is exactly indicative of if they would have landed here and started to fill up and then migrated down. And the more they migrated down, they would have lost and had more chromosome fusions and lost genetic information over time. It's exactly what we see. And now on to the next animal, the giraffe. Oh, look at that little picture. Let me fix that. Didn't work. Okay, then. Okay, the giraffe. This is on the ark encounter. Again, we don't find a typical giraffe like you would see today. We find a short-necked giraffe species. And they still are alive today in different provinces around the world. And most giraffe species are actually in Africa. So when you look at a map and you pull up the giraffes, you only find 4 species and then subspecies underneath them. And all 4 of them are only living in Africa today. And most of the species are, you can find their different patterns and how they got named. But if this was true and this was the species that was on the ark and it got off, again, we don't necessarily know its chromosome number, so we can't really say if it's an absolute positive. But what would the migration patterns show? They would show that they would probably get off the ark and they would migrate into Africa, up to the north and away from the ark. And that is literally exactly the pattern that we see when we found their fossil evidence. They match that pattern perfectly. So though why we don't have their genetic information, the I guess you could call it a guess that the ark encounter made. I don't know if they've ever seen this map. I found this one online. It was absolutely perfect that someone had made. This isn't at the ark encounter. This is an evolutionary book. And the pattern matches absolutely perfectly what we would expect to find as species went into Africa. The glacier melt happened. It swept away the green of northern Africa and left a Sahara desert. It wasn't able to leave. And over time, their necks stretched out and they speciated and they lost information again over time. And this species went extinct because of the terrain wasn't very good. They weren't able to probably eat, which is probably why their neck extended, right? Trying to get to the food that was much harder for its lesser counterpart to be able to survive. And so that would be the species on the ark. I would say that Answers in Genesis was actually pretty accurate and they got it right. And it's simply based on the migration patterns. I can't validate that with the genome evidence and chromosomes because we don't have its sequence. We only have the fossil record. But lo and behold, it matches exactly what we would expect to see and what we have seen so far. So let's jump into the next one, which would be wild sheep. Where did they come from? We're going to, again, use the exact same indicative patterns that we would expect to find. I found this list online. You couldn't read that very good, so I did everyone a favor and made a better version. And we will be able to follow the chromosome count going from where the ark would have landed right around here. And we will see that the pattern is kind of wild. We find, though, again, very, very similar patterns, that the branching out, leaving this area, we have a lot of species. Now, goats are migrators by nature. They travel, they leave, and they migrate. And in doing so, they land in new regions. What is going to happen is a new species is going to form because they're now living in an area where, oh, it's cold, it's snow. Boom, new species. Some went south. Oh, it's warm here. Don't need a thick coat. So that's exactly what happened. And this is a lot of the species that we find are around, again, Europe as being the mecca for all of the diversity for these species. And then I put the ark here so everyone could see where the ark would have landed in the region, kind of near the Fertile Crescent, but north of it, into the Turkey, and then bam, a branching out pattern. And what species do we find has the most amount of genetic diversity in it, the most amount of chromosomes? You're going to find that in the mouflon sheep. So the mouflon would have been the one that was on the ark, has the highest amount of genetic diversity built into it, and has the pattern, the most richness around that region, and then bam, spread out. And again, that's exactly what we see. And so when we look at the mouflon genome size, we find that it is the largest. And when we look at the more modern species, we find a loss over time. So what was on the ark? It was the mouflon. It was the species that survived. And we're going to jump into that in a little bit, because there's a really cool story about how just a single pair of them were left on the Kruligan Islands, and they got off and completely survived very, very easily. But before that, we're going to get into, what about the chicken? We were told that the Tyrannosaurus Rex evolved eventually into the chicken because it is the most genetically related to the Tyrannosaurus Rex out of all living creatures. However, when we go backwards in time and we look at the chicken, we actually find something different. We actually find that the red jungle fowl is the ancestor to all other living wild chickens. And it, again, is the region that would be closest to the ark over here in Turkey, came down, filled up the entire region. And then we had speciation events, chromosome fusion, genetic loss over time, and we have new species forming. And we can say that without any problem that they did a pedigree mutation rate study on chickens to determine when was the ancestor of all chickens. And they found the exact same thing that we would expect to find in all pedigree mutation rate studies, which places human beings only a few thousand years ago and not hundreds of thousands of years ago. We found it with the chicken. That said, it was 15 times faster than they expected to find based on the evolutionary timeline. The reason why is because evolution is not true. Once they eventually abandon this horrible idea that the molecular clock needs to be calibrated to the fossil record, because the fossil record is not true, they'll have a more pattern that's going to match the biblical timeline. And they've done that with some animals, worms, flies, water flea. They've done it with crocodiles now, and obviously chickens. And the chicken ancestor goes right back to the ark. It doesn't have a common ancestor that goes back to some dinosaur that the Tyrannosaurus Rex was evolving into or from. All that is nonsense. And we can pretty much say that the ancestor of the chicken that was on Noah's Ark was the red jungle fowl. That is what the genetic evidence shows. Again, if there was a species that existed before it that went extinct, we don't know. We don't have it. But this, again, would be the best bet out of all organisms on the ark. Now, the most interesting, controversial one yet, and this is the horse species on the ark. Now, the Answers in Genesis has the small, tiny horse, Eohippus. And this is the tiniest of all horse species. And when you look at it compared to modern day horses, you can see very, very different, very, very small. So the Ark Encounters placed this horse on there. I'm not exactly sure why. Whether or not it was the belief that maybe because it was small, it was easier to take care of for Noah, or whether or not they had another justification for it. I couldn't find its genome sequence anywhere. But when I look on a map, This is the only region they've ever found their fossils in, and that was in North America. So based on this, and based on them being the first species off the ark, and based on the evolutionary version that they are the first horse as well, what are they doing only in North America? We don't have any indication of a migration pattern from where they would get off the ark and run over there. And the answers in Genesis, I can't find anything that explains why they placed them on the ark in that region. So now let's go to the genetic evidence and what we can kind of deduce. If we look at the first horse off the ark based on chromosome count, we're going to get into the wild horse. The oh man, I don't even know how I want to begin to pronounce this one. Przewalowski. This horse is so wild that when they tried to tame it and put it in captivity, they were unable to. They stopped breeding and they almost went extinct. They went into a bottleneck as well, and they came out of it, and then eventually went into another one later and died off, I believe. So I don't know if how well they did. Obviously, that picture, they're alive today, but we have their chromosome count, and we know where they originated. They're right here in the Middle Eastern area, exactly where Noah's Ark landed. And then we go to the next horse, which would have lost 2 chromosomes. So now you're down to 64, and it's a wild horse. We find them all over. Again, as they branch out, we see that they've left the area and they've lost chromosomes. Then we're going to get into the mule, which is in northern Africa. It's down to 63 chromosomes. Then we're going to get into the donkey, which is a little farther south into Africa. It's down to 62 chromosomes from a fusion. And then we get into the zebra, which is in the south. It's down to 33 chromosomes. So the pattern absolutely perfectly matches the biblical model of chromosome fusion and loss over time, going back all the way to the ark. So this is, I believe, at the Ark Encounter, they're showing that the changes of the horse could have easily happened, and that the variety that was on was this very small horse. But genetically, I can't prove that, and I have a different theory about why that is. But why are there no horses in North America? Probably the climate change. I think it's pretty obvious as well. The reason why is because you have an ice age, and the horses that migrated into that region began shrinking as they got further into North America. So we see that this variety of horse, there was no horses in America until about 500 years ago. And the reason why, here's an evolutionary chart. So they believe that, again, the horse originated in North America based on the fossil record and based on that smallest horse originating there, and that it migrated into the different regions. And I'm going to give a thing that shows the exact opposite. So we find in the Bering Strait, when we look at these different horse species, I'll show you the list again. We find that the species, as they went in, instead of leaving, as they went in, they shrunk and lost genetic information over time and lost their size and eventually died out and went extinct. Not they didn't leave that area. See, that belief is based on the fossil record. The belief that the layers represent time, and therefore the layer that they found that small horse in, being the deepest, must make it the original horse, when that's not the case whatsoever. And the reason why is because during that ice age, this would have created a flood over North America. And we have that evidence. And that's why those layers are there. Instead, we have horses leaving the area. And the farther they get, the more chromosomes they lose. So when we sequence eventually one day these other horse species that they believe were the ancient ancestors, we're going to find the pattern that matches the biblical model of ancestry and this model that I'm talking about today. And that's a prediction that I'm making now today of what we're going to find. And so why is that? Because Occam's razor. This is the answer that makes the most sense. It's the most common sense with the fewest assumptions that we can lay down. And this is based on the biblical model that we're just saying, hey, look at this. If something were to get off the ark and travel around, and if genetic entropy is actually true, what would we expect to find? We would expect to find a generalized pattern. And that's what we see. That's Occam's razor. It's common sense. We don't have to deduce all these other things and build stories off of them based on one little tiny aspect. Let's look at all of the different aspects and then tie them together. Does it make sense? Does it match what we see? It does. Therefore, it's probably the one that's the most true. That said, what about Australia? They call it the Mecca of marsupials, their origin, right? It branched off and broke off of the south tip of the pole and moved up. And this is where marsupials evolved. And then they branched off and started traveling around the world. But again, let's see what the biblical model would predict. So, oh, look at that. African marsupial or dispersion. Marsupials were present in northern Africa. But what were they doing there? Why? We're never told that they were in Africa or these other places. This was the Mecca of their first thing. So what's going on? We find the ancient mammal ancestor found in ancient China. Now it's changed. It's actually moved over into the China region where the ancestor from it all. We also found a small marsupial jaw in Africa, in Egypt, for exactly where that would be. So now we're getting closer again to where the ark landed, and the migration pattern would have got off. They would have probably migrated there, not by necessarily walking all the way. Remember, the floodwaters would have been higher. They would have gotten off. They would have probably caught a lot of water currents. But that doesn't mean that they can't migrate. A lot of them can't migrate anyway, because we find that they do. Now, a lot of people go, you expect me to believe that kangaroos hopped all the way over there? Well, why not? Because we've actually found cave drawings now of kangaroos, not in Australia, but rather we found them in India. So what are they doing there? Why would they be in India when they supposedly never lived in that region whatsoever? They supposedly only grew and lived in Australia, never got off, but yet we find that they would have moved towards Australia and then gotten trapped. But why? How would they have gotten trapped? Well, the reason why is because of something called the Wallace line. It was discovered in 1863. And this line that runs right through here on the northern part of Australia has something very interesting about it. It blocks animals from crossing because of high wind patterns and water current. And the species, although almost related to one another across the line, are completely different, and they're incompatible with one another. So they're so different that they noticed that, like, what's going on? I can see the island with my eyes, but the animal species on it are completely different, and they never come over here. Why is that? So what happened, pretty obvious to me, is that when they migrated over into Australia and the water levels rose, that Wallace line formed because now there's water current running through the region and the wind patterns are very strong, that the animals, it wasn't because they could they were trapped here and evolved here. It's because they couldn't migrate back off. So they eventually adapted to this region and they stayed. Pretty obvious and pretty logical. So now what do the people say? Did marsupials actually evolve in Australia? Marsupials absolutely categorically did not originate in Australia. That's what we know today. And that's because we keep finding evidence of them not originating there, because we find them all over the place. Why though? The reason why is because, again, we would expect to find that they would have gotten off the ark, they would have started to migrate around, and they would have left fossil evidence of their existence as they were finding the niche best for them to live. Anything that went north didn't do very good. So where would animals go? A lot of them would go south, right? So there's only two real places to go. Down here where it's warm, down here where it's warm. That's exactly what we see. Lots of animals down here, lots of diversity, lots of animals over here, lots of diversity. The only difference is they became trapped. These ones also kind of became trapped, but only because of a desert, not because it became landlocked. So I hope that answers the marsupial question and the kangaroo question. It's exactly what we'd expect to find. Next one. How about Noah and his own family, right? We can go to human beings. Human beings are an interesting one. So this, again, was taken from Answers in Genesis. This was the map that they have that shows the possible regions where the ark could have landed. There's a wide variety of area right here. It's quite big. And where is the Fertile Crescent believed to be the very Mecca of the first settlements ever found. So interesting, right? That the ark would have landed in this region, and humans would have gotten off and migrated and to probably a close region where it was convenient. Again, that would be south, going away from the snow, and they would have started farming. That's where we find the earliest domestication of animals, earliest crops, earliest writing systems, earliest culture and civilization. It's not in Africa, where they had supposedly lived for 200,000 years doing nothing. And what would we expect to find when it comes to genetics? Well, haplogroups would have formed in that very region, right? Because that's where the mecca of human population was during Peleg's generation, when they were building the Tower of Babel and dispersion began. Well, how about Africa? What's going on there? I thought humans originated there and lived there for 150,000 years before they ever ventured out. Oh, look at that. They don't have very many haplogroups in the entire region, but yet they lived in small tribes and they filled up the entire continent. Why are there not more haplogroups forming like there was at that region at that time? It's pretty obvious, because it's the biblical model of ancestry matches exactly what we expect to see. Then they want us to believe that a primitive, dumb human went into a global bottleneck. There was a massive die-off of all human beings, and modern man came out the other side and left no trace of that transition whatsoever. But these dumb, primitive brutes that only lived in caves, had no writing system, no nothing like that, probably didn't talk to one another. All their predictions on these guys were completely wrong, by the way. They would have left us with modern humans. We would have came from them. They would have been probably a hybrid speciation event. They're called subhuman. There's all different types of names for them. But what do we know? We know that human beings came from mostly this region right here, based on following genetics back, following the haplogroup explosions back. They believe that if you follow them on one thing, Africans having more mutations, that must place them in Africa. We say no, not everybody has the same mutation rate. Therefore, when you look at the overall substitution rate, you're going to find that varies. And Africans have more PRDM9, which means they have a faster substitution rate because they have more recombination. Therefore, they look genetically older, but they're not. So what would we expect to find then, going backwards in time? What would we go back if we went to Noah, who was on the ark? Would we find that ancient ancestors of human beings, humans themselves, had bigger genomes in the past? That's right. They actually have 40.7 million more DNA base pairs than people do today. Well, wait a minute. That's almost as big as the entire Y chromosome. It's 60 million. So wait a minute. That matches our model. I thought humans, remember, evolution teaches that things go up in a linear pattern and they branch out. They call it common descent, but they should call it common ascent, because it's things ascending from a common ancestor of bacteria-like species and creating all these new ones that we see today. But instead, we see 3 lines of human beings that would have gotten off the ark. They would have diversified, started to move around. They would have gone extinct, just as people would die off today that move to different islands and have to live off the land. Some can't do it. During the time of Noah's flood, you got to remember, there was an ice age. There was harsh places. Noah would have had massive amounts of genetic diversity within him, and it would have gotten lost just as it would with any living creature based on the genetic entropy model. And knowing that, we can say, okay, well, that means that Noah would have had superior genetics, and that explains why he was able to live so long. And then over time, his kids, having them at such an old age, would have caused massive amounts of mutations to get passed on. And then by the time the Tower of Babel, the diversity of human beings, though built into people, we would see a loss over time. And look, that's exactly what we see today. There's a huge loss of morphological and phenotypic diversity in human beings when we look in the fossil record at humans, at what we know are humans. So what would we expect to see based on phenotypic diversity then when we look at human beings that would have gotten off the ark, as opposed to evolution? Well, remember, evolution tells us that human beings have been in Africa for a very, very long period of time, and that Africa has a massive amount of different regions. They have high plateaus to beaches, lowlands, tropical rainforests, deserts. They have everything. So the most amount of phenotypic diversity should be in Africa, but that's actually not what we see. We see phenotypic diversity between every ethnic group is exactly the same. Now, that is exactly what we would expect to find in the biblical model, as opposed to evolution, which would have everything phenotypically nearly identical to one another. We find that phenotypic diversity between the primates identical with one another. And then we find a massive variety of phenotypic diversity in human beings because Noah had massive amounts of phenotypic diversity built into him and were not related to the primate ancestry line. Instead, we have the Tower of Babel that we can thank for the dispersion of people because we didn't know any better, but God did. You see, God knew that if we were to keep in one region and not diversify, that we would inbreed with one another, and that would be a detriment to us. He said, be fruitful and multiply and fill the earth, not stay in one place. We didn't obey that, and we got in some trouble for that. So he forced us to by language. So if we were going to be looking at the diversity of phenotypic change of human beings, all humans would be about the same age, and their phenotypic diversity would show that. They would show the exact equalness between us. It's exactly what we see. Between wild animals, we have humans have the same diversity against every ethnic group, which I mentioned earlier. Phenotypic diversity between humans is high, but between chimps is very low. And you can go back to the fossil record and find the exact same thing with any primate species that you want to look at, no matter where they lived on Earth. It's always low. Human beings always high and diminishing over time. Then we look over at Neanderthal, which we covered a little bit ago, and the evolutionary idea was that they were primitive brutes, and their predictions on that falsified. Today, we know that they were normal people that had pale skin, red hair, freckles, and about 5'6" to 5'8", and really strong and thick, made for the cold. So that might bring up the question for you guys then. Well, what about the integration? How come there's not much DNA for Neanderthalians today? Because we actually know from a study now that it only takes about 10 to 20 generations for people inbreeding before they're, you can't tell it anymore. It only takes a handful of generations. And then there is no more ability to tell how old they are anymore because you reach a saturation point. So after 20 generations, all individuals have nearly the same amount of Neanderthal ancestry. So 20 generations isn't very long. We go back about 150 till we land on the ark. So clearly 20 generations passing isn't that much. That's pretty obvious why we still have some, but why it's the same in pretty much everybody. So what would we find if evolution was true? We would find a convergence going back in time to a primate missing link ancestor, or do we find these independent lines of ancestries following mutations back to an individual line? That's what we see. We see individual lines of ancestry, not the evolutionary assumption idea. And then when we look at the fossil record, we find something interesting. We find that primates actually exist in different fossil layers than humans do. All humans are only found in these layers. So we find that they didn't migrate into regions as fast as animals did. And why is that? Because when the ark landed, human beings stayed together. Animals did not. So humans stayed together until the Tower of Babel, which was over 1,000 years later. So what's going on is we have animals that migrated right off the ark. They went into Africa, and Africa was lush and green at that time. And the animals that lived in that region, they were doing just fine until that melt off happened. Humans hadn't even inhabited that region yet. There was nothing even there for us. So it went from a green to a desert in a flash. It went that way extremely fast. And what would we expect to see? Well, we should be able to see that on the continent today. And we actually can. If you look at the continent, we can actually see where the water rushed over it in this region during that ice age melt glacial runoff. And you can still see the signs underneath the ocean of the sand that had moved into it. You expect that to be there over hundreds of thousands or millions of years when they believe the ice age was really going on and may have caused some of this? No way. That would have been gone. So here's a study that you can see where they talk about the ancient seaway that covered it, and it actually matches the timeline. Look at this. They believe that it happened between 8,000 and 4,500 years ago. What does the biblical model talk about when this event probably could have happened? 4,500 years ago is exactly when Nathaniel Jensen found the Y chromosome for Noah, right in that timeline. So amazing. Everything matches yet again. Why is that? How come things aren't genetically converging on this missing link common ancestor? They don't do it at all. Instead, there's exactly what we would expect to find from the biblical model of ancestry, where everything has independent lines of origins, including animals. And this has already been done. Matter of fact, science textbooks, they already tell us that they don't want to even admit or even put it on paper. The Evolution 101 Handbook has 49 tree of life drawings in it. Not a single tree includes the name of a single common ancestor. Think about that. Not one. They have no genetic evidence for any of this tree of life that they're talking about. They don't have any of the genetic or fossil evidence of any of these things. They're hoping that they do. Matter of fact, there's not even a single trace of geological global event that happened 200,000 years ago when they say that this global bottleneck actually happened. So they have a global bottleneck that happened. So they go to their own fossil record that they made up, and they actually can't find any evidence for it. Instead, they find the exact thing that we've been saying and predicting over time, which was that species have clear genetic boundaries, that there's independent lines of ancestry that go right back to the ark, and there's no in-between species. Look at that. Right on paper from the evolutionary community themselves that debunk their very own theory. They did it to themselves. It's amazing. And look at that. They even aquatic life, they're so confused by this. They even says, did herrings really pass through an equally recent population bottleneck and anchovies? They're left with such confusion, right? They have no idea what to even say to that because it doesn't make sense. I can't throw up the next one. Sorry. That one is broken for some reason. So it is thought that we split from a common ancestor from chimps 5 to 6 million years ago. Now it's about 7. They keep adding time, but yet that's a substantial amount of time for all the genetic diversity to be there, but it's not there. So this discovery co-founds the predictions from population genetics theory that older or larger populations should show more diversity. We see the biblical model of ancestry when we look at genetics and when we look at maps, when we look at diversity, you name it, phenotypic diversity, you're going to find the population, everything matches this biblical model of ancestry. The span of human recorded history is only 5,000 years. They really expect us to believe that humans lived for more than 200,000 years, but the last bottleneck, which was us modern humans, came out 200,000 years and just sat around and did nothing for 150,000 years. We couldn't do anything. And then for another 45,000 years, for a total of 195,000 years, we couldn't figure out how to farm, write, do agriculture, domesticate animals, write down, looking at the stars, mathematics, but yet we just pop out of nowhere. 5,000 years ago, we know how to write. We know how to do every one of those things, build pyramids perfectly to like star systems. It's just, their story is so flawed, it's ridiculous. Then when we look at the assumptions based on evolution, we find that they base their assumptions on the fossil record, what I mentioned earlier. They base it on the assumption that the fossil record must be true because evolution must be true. But yet when we look at the observed rates, they're much higher than the evolutionary assumption rate because the evolutionary assumption rate is not true. And we look at the mitochondria, we see going back all the way into the 90s, some of the earliest studies already showed us that the mitochondria Adam and Eve, lived about 6,500 years ago. One of the largest studies ever done. It was actually replicated the following year. Then when we go into other genetics, when we look at SNVs, we find that, oh, look at that. Human diversity rapidly explodes about 5,000 years ago. Oh, shocker. I wonder when that was. Oh, look, Peleg's generation. So they admit this, by the way. They admit that Africa is inferred to be the continent of origin for all human populations, but the details of the human prehistory of evolution in Africa is largely obscure, owing the complex histories to hundreds of distinct populations. So they don't even know. They said the African human population are mostly genetically diverse in the world. That's why they believe that they're the oldest. But inference about African demographic history, evolution, and disease association has been limited by relatively few genetic samples and scarce archaeological remains in many regions. So they admit we don't find the evidence, but it has to match the evolutionary timeline. We infer it. We assume it's true. We have a little bit of evidence, but we're just going to go with that anyway because that's what we've said. But what do we find? We find regions like the CO1 gene in the human being is actually mutating and it mutates at a very slow rate in human beings. Matter of fact, the most diverse human in the world only have 10 mutations in that region. That means that the vast majority of humans today have no mutations in that region. You know what that means? That means that people are walking around right now, and in the CO1 gene, in the mitochondria, they have the same base pairs and sequences that Adam and Eve had. That's right. So we can actually know Adam and Eve's sequences based on human beings alive today that don't have any mutations in that region. So if we look at that mutation rate, again, we look at it in animals and it's fast, and we can trace that back to a common ancestor, and it's always an animal. And that always gets people. They always say, well, what do you believe, that all these animals just had incest and humans just had incest with one another? Absolutely. And we have evidence that that can happen even today with animals, and it's no problem whatsoever as long as they follow God's command of being diverse, multiplying, and spreading out, not staying in small groups of people, which mankind always tried to do and God frowned upon. So we have the creation and a global bottleneck going to the flood, and then people getting off and merging together until there was another bottleneck of the Peleg's generation where the languages were confounded. And then they branched off into the world that we have today. So we have people with perfect genomes that were living for almost 1,000 years going onto the boat of Noah's Ark, and they got off, and Noah, having children at such an old age, plummeted that lifespan, and they began dropping off drastically at that time. With animals, it's a little bit different. They weren't living hundreds of years like human beings were, but we can still find that when they got off the ark, from a single pair, we can find that wild sheep immediately got off the ark and would have been easily able to populate the area, just like they did on these islands, the Mouflon Islands. And we can find the same thing. Here's one with rabbits. They took 24 British rabbits and took them over to Australia. Well, guess what? There are tons of rabbits now, approximately 200 million feral rabbits around Australia. So it's a complete disaster over there. How about deer? There was only 5 white-tailed deer, 4 female, I believe, and 1 male. And today they overpopulate. You can go there and you can hunt them all that you want. So there's 7 new deer species in just 80 years. Think about that. Massive amount. There's 100,000 deer there that you can go and hunt at any time, all from 5, 1 male. So clearly this is possible. How about when they took a herd of only 14 American bison over to a Catalina island for filming of a film, and they dropped them off and just left. They populated, no problem. Inbreeding didn't kill them. They diversified and spread out and grew in population. There was no big deal. So we have mutations increasing from Adam and Eve, and then again the flood. And these mutations accumulation allow us to test different things. And we would expect to find, because it's so fast, that everything is fast. Rapid adaptation is very, very quick. And when things were to get off the ark, you have a world that's completely empty, ready and prime for animal speciation and diversity to just explode and grow. And now we even know that even today, with a lot of these niches already filled, that animals are diversifying way faster than Darwin could have ever imagined. And they're actually trying to rewrite the evolutionary theory with a new concept called plasticity, where they talk about how fast animals can actually change. Not this slow progression over time, but there's limits to what they can change into. That's the one thing that evolution doesn't draw the line into. You'll never meet an evolutionist that can tell you what anything can evolve into. You know why? Because evolution is just random. Anything can do anything. That's why it's not science, because it's unfalsifiable. They can't even make predictions. If evolution can do anything, go forward, go backwards, completely stop. It can't make predictions. It's just garbage. So they won't be able to tell you ever what anything could evolve into. Just ask them. Just put them on the spot. Say, what will one thing evolve into in 50,000 years? They can't do it. Why? Because evolution is nonsense. That's why. So we have example after example of animals changing rapidly. We have elephants that lose their tusks in one generation because poachers are killing them. It's almost like their body knows why they're dying and they change. We have birds changing wingspan from long to short so they can be more diverse because they drop off a freeway on ramps and they have to lift real quick before they get hit by a car. Boom, instant change. It's amazing how rapid these changes are. And so when we go back, are we able to go, well, what is Adam and Eve's genome? We talked about the CL1 gene in the mitochondria. Can we actually look at the entire genome? Yes, we can. Dr. John Sanford and I believe Robert Carter figured that out. You can actually see Eve's sequence. So we're going to ask ourselves, what makes more sense? Is it creation, where there's just a single bottleneck, which is one generation, and then people can get out and diversify very easily? Or does it make sense that evolution has multiple bottlenecks where only a handful of people survive over thousands of years, inbreeding with one another and not diversifying, only living in small, little, tiny groups in small demographics and places over the earth over eons of time? That makes no sense. They make fun of us for having an inbreeding problem. They have an inbreeding problem. And it's not just with humans, it's with animals as well, because they have bottlenecks going on that last for massive amounts of time. So that brings us to the next question. What one is actually used? Of course, they use the phylogenetic mutation rate, but only in the laboratory, only with making assumptions about fossils. What does actually get used in the medical field? Well, this is the NIH, the National Institute of Health that you're looking at. And they actually use Mendel's accountant, which was created by young Earth creationist Dr. John Sanford, who actually became a young Earth creationist, by the way, because of his discovery of this genomic decay over time, which he coined genetic entropy and wrote a book on and videos. And he actually made a prediction based on the simulation that he created here in Mendel's accountant that showed that human beings only have a generation maximum of 350 before we go extinct from genetic decay. And this is what's used by the National Institute of Health to predict the branching out of how mutations sweep through a population. And it's that accurate that they don't use some evolutionary model of assumptions. They don't care about evolution versus creation. They only want to know what works. They don't use evolution. They use the biblical young Earth creation model. They use the one that works. So if that interests you, learn about that, and you'll see why it's so good and why the predictions are so accurate and how it actually works. I wrote a book just recently called The Quest for Noah, and we go through a lot of that, a different kind of evidence. And it's a small book. I believe it's only about maybe 80 pages, but it's on Amazon and you can pick it up for less than $4. It's cheaper than a Starbucks drink now, a gallon of gas. So we don't cover the animals, but we cover human beings, and we go on a quest for Noah to determine if he was a human being that literally existed, when he did, all of it. And I take you through the journey of as deep as you can go for as small as I can make it into a book, and as cheap as possible for everybody. So I hope you check that out. So today we've covered over 10 different animals. We didn't get in depth on cats or dogs, but we went over wild boar, beavers and bulls and rhinoceros and no, we didn't do elephants. Could have, but if you guys like this and you want more of it, pick an animal. Pick one. It doesn't matter. It's going to match these patterns. Do you know why? Because it's true. It's what's real. The biblical model of ancestry is true. That's why all of these things keep lining up and matching it. It wouldn't match. As a matter of fact, you wouldn't even be able to find very many of these at all. Why? Because the world is huge. The world is massive, and you would find animals evolving in all these brand new niches and popping up in existence in different places. You wouldn't find the pattern that so easily and accurately matches the biblical description of exactly what we would find if animals were on an ark and got off. You wouldn't find those genetic boundaries. You wouldn't find the genomic decay, genome loss over time, chromosome fusions that match these patterns. So I think we've narrowed down quite a few animals that were on the ark. So there's going to be some that are, like I told you, very, very tough, because if a species is extinct, we have to exclude them from really being on there unless we can positively go, this pattern in the fossil record can be backed up with some other genetic evidence. But you want to take as much as you can. Don't look at a little narrow thing like the evolutionists do and try to build an upside down theology and have a whole pyramid built on stupidity because they want it to be true. Don't just look at these narrow-minded little aspects of one trivial thing. Look at it all. And when you look at all of it, you're only left with one answer, and that's the biblical ancestry model. And you'll find how strong it is. You'll find people that won't agree to it, but they're not looking into it. They're not actually researching. They're just complaining. They're too emotional about the subject. Just dive in, look at it. You'll be shocked. You'll find it and you'll go, wow, this is crazy. I never thought I would expect to see that. So pick an animal and just run it through the database and look at it for yourself. You don't have to trust me. These are easy things that I found. I just randomly picked animals. I mean, why would all of them be so easily picked and match the pattern? It's like you could just pick any animal. So do it. Obviously, birds would be a bad one. They fly. So pick just something on the land. Pick an animal. Other than that, I guess that does it. I will stop screen sharing and we will wait for Donny to get back. Actually, I guess I can keep screen sharing until then. Oh, you're back.
I'm back. That flew by, my brother. As always, excellent job. Tons of information for people to digest and to absorb. The critics are going to have a tough time with this one. Isn't that right, Matt?
They're just going to deny it like usual. It doesn't matter. You know, we've come to the point now where you're fighting a circular argument. You know, you show them your examples of like, look, there's no evidence viruses arise from outside of any. It needs a host. There needs to be a place for a virus to arise, and they're just they fight basics. You know, right. This is going to be the same thing. They're just going to complain,
rescue devices, but not offer any real solid testable predictions themselves. Isn't that right, Matt?
Yeah, we're used to that one too. I made testable predictions even in this one. They won't do that. They never do. Me and you are probably up to over 10 testable predictions ourselves in books, maybe more.
So, and I know this is something you address all the time. What about the critics that say, well, there's just far too many species, millions of species today, to come from just a few ark animals? You know, in 4,500 years, isn't that hyper evolution? And so they would accuse somebody like you or myself of believing in more evolution than they believe in. Matt, what's a good response, brother?
The best response to that is saying that the type of evolution that they believe in is a very different version of the evolution that we believe in. Their version of evolution requires beneficial mutations to reach saturation and a new species to arise from that. That would be a very slow process. Speciation isn't driven by that. So our version of a new species is something that can happen from a hybridization event within 2 generations. We see that today with Darwin's finches. Darwin based his belief of evolution based on deep time. So when he saw the finches, he said there should be a new species of finch arising every 3,000 years. That was his prediction based on evolution. We now find that those very finch species have a new one every 2 generations. Think about that. Think how wrong he was. That's massive amounts of diversity. Every 2 generations, are you kidding me? That's a huge amount of diversity, and it's rapid. And the reason it's so rapid is because animals would have gone through what evolution likes to call punctuated equilibrium. But they believe that that's a real slow process that jumps. So I use a different name. It's called rapid radiation. And rapid radiation is just change of allele frequency really, really quickly. And animals do that today. You can create your own dog breed today just by mixing and matching. So if you can do that right now and have a new breed of dog, nature can do the same thing when an animal migrates to a new region. So imagine a whole world being empty and animals go into a new niche and they have to adapt. There's going to be a new species within just a couple generations. It's not going to take millions of years, but their version is. And they have these no boundaries, right? They don't have a taxonomic boundary paradox in their own mind. They do on paper, because it's true. There is a taxonomic boundary paradox, but they don't believe it because theirs requires imagination.
Great answer. So since we see extant animals like tigers in Egyptian mythology and hieroglyphics, right? Does that mean extant animals must have come about rather quickly after the flood? Let's take an ark archetype for a cat. Steps foot off of the ark. From there, you would get extant species like tigers or a leopard or a lion quickly, Matt?
Exactly, because all of them can interbreed with one another. So we know they're very genetically related to one another. And their genome seems to be very, very strong, as where some species aren't very strong. So it doesn't take much time for them to diversify and no longer be able to breed with one another, their own kind, you can say, as where cats can. So like let's say a lion got off. And so lions now have more babies, and some of them go into the southeast and others go into Africa. So now you're getting they're going into entirely different regions, and they're adapting to those regions very, very rapidly because they need to. Some go north. Well, when you go north, what's going to happen? You don't want to have bright stripes and colors. You're living in the snow. You better change your pattern very quickly. So they got like a lion, right? They became a saber-toothed tiger. Why would they need such big fangs? Well, it's because their food sources are a woolly rhinoceros, a woolly mammoth. They can't puncture the skin of those animals unless they adapt very, very quickly. So they did. As the animals, as the elephants started to grow wool to protect themselves in the cold, well, their fangs grew at the same time. These are rapid changes. These are epigenetics. And when you look at the epigenetic changes of these phenotypic differences that change, you'll find that they're on regulatory genes of epigenetics, which is amazing because they change so quickly, as opposed to other parts of the genome, which can change slow. So these physical differences that we see, they're very, very rapid.
Right. And so because a lot of the allelic diversity you're talking about, these pre-existing DNA differences, because they're front-loaded at the start, then new varieties, new chromosomal combinations on a genotypic level can come about rapidly since those differences are built in.
Right. Now imagine what would have happened if God would have sent Noah a chihuahua. It would be a disaster for the canine species because it would probably have just gone completely extinct, right? I mean, it doesn't have much genetic information in it. How many more species are going to be able to come out of a pug? Not many, and probably nothing good. You're going to be very, very limited. So, but we go back in time when we get to the wolf, we have a much better genome. God sent a very diverse animal species onto the ark that would be able to survive until modern times and perform whatever role and task God designed it for.
Now, what if a critic said, okay, created heterozygosity or design diversity at creation, but at the flood, you have this massive universal bottleneck. And so that should have removed most of the pre-existing genetic diversity to be utilized post-flood. What's a good response to that, brother?
There could have been a lot of animals that died. Let's take, for example, the goat species, right? There could have been something other than a mouflon that existed before, and that would have been maybe even had more genetic diversity. We won't know that because its genetics are gone from us, and we can only look at the fossil evidence. But when we do look at the fossils in the past, what do we see? We see massive amounts of species. Massive, like 90% of all the species that have ever lived are gone, and there's massive amount of diversity. But yet, when we look at the Earth back then, we actually find that most of the Earth was a beautiful tropical place in the world. It didn't even have as much as the Earth does today. So we actually did lose, I believe, a lot of genetic diversity in life by the time it got onto the Ark, because whatever. So God didn't necessarily create a mouflon sheep. That's what I'm saying. And then send that species all the way to the ark and retain it. Human beings are different. We don't speciate. So when we got on the ark, we got on very, very good and superior. And Noah was the man. He could live for 1,000. If he had children younger, people today would also be living for hundreds of years.
And do you think it's plausible or logical that God would have sent the most heterozygous pair of animals at that time, let's say in terms of the felid kind, canid kind? Wouldn't it make sense that God would send the most heterozygous pair onto the ark in the first place?
It could, for sure. He would know what it needs to do to survive, right? He's the one sending it to the ark just for the survival reason. And so, he's gonna know that, hey, when this flood happens, the earth is going to be different. There's going to be mountains, massive mountains. There's going to be snow. There's going to be deserts. There's going to be tropical. There's going to be rainforest. There's going to be a massive amount. So if I don't put an animal on there that's going to have this diversity to expand rapidly after, then there's no reason to put the animal on the ark to begin with, because it's just going to go extinct. And it also brings up other questions too. Like, what about dinosaurs? Did God send a dinosaur just to get off the ark and go extinct and die? or did he actually create them to also live? I would say that he created them to also live, but mankind killed them off.
All right, brother. Very good. I think this was an excellent presentation. You did a, excuse me, fantastic job answering those questions. As you know, I'm still recovering from strep throat and a little pink eye, and your family's recovering from a bug as well. And so the joys of October, November weather, my brother. So,
I know, right?
okay, that's one of the reasons why we pre-recorded instead of go live, as it's a lot easier on the both of us. So to those tuning in, though, stay tuned, as we do have another 2 shows tomorrow, session 3 and session 4. Session 3 with John Mackay and Joseph Hubbard, and session 4 with Anthony Rogers. And both of these will be live in order that we can take your audience questions. And with that, we're going to wrap it up. This was session 2 of our Defending Genesis Conference 2023. For those who haven't yet seen Defending Genesis Conference 2022, please check the description box or the channel or the website. As last year, we did the same thing, 10 events, hours and hours and hours worth of material on many important topics. So with that, Matt, great job, brother. To the audience, share this content around, as the truth is important. Standing for Truth is out.